For most of the 20th century, there was a definitive answer to one of the oldest questions in American science. When did the first people arrive in the Americas? The answer was printed in textbooks, taught in lecture halls, and repeated across generations of students from Alaska to Argentina. Humans crossed into North America from Siberia around 13,000 years ago through an ice-free corridor between two retreating glaciers. They left behind distinctive stone tools called Clovis points. Those tools appeared everywhere, almost simultaneously, spread across the continent in what looked like an explosion of movement. That was the story. That was the science. It was wrong, not slightly off, not a matter of minor revision. Wrong by nearly 10,000 years. In September 2019, a geologist named David Bustos and an ancient footprint specialist named Matthew Bennett of Bournemouth University in England were working inside White Sands National Park in the Tularosa Basin of south-central New Mexico. They had visited this particular bluff more than a dozen times before. They knew the site. They knew the sediment layers. They had not found human footprints here. On this day, the wind had shifted overnight and scraped a thin layer of white gypsum sand from the surface. And there in the dried mud beneath it was a row of human footprints, flat-footed, clearly defined. Toe pads and heels pressed into sediment that had been wet roughly 22,000 years before anyone was standing there to look at it. Bustos described the feeling. They knew immediately what they were looking at. They also knew immediately how impossible it was supposed to be. To understand why that matters, you have to hold the old model in your mind long enough to understand why it was so convincing. The Clovis first theory did not emerge from carelessness. It emerged from a specific, spectacular discovery. In 1929, a 19-year-old amateur named Ridgely Whiteman found stone tools near Clovis, New Mexico, buried alongside the bones of Columbian mammoths. Excavations through the 1930s confirmed it. Humans had been here at the end of the Ice Age, hunting animals that were now extinct. The tools were elegant, long, fluted, lanceolate points, unlike anything found anywhere else in the world, and all turned up everywhere. Montana, Virginia, Texas, Florida, Mexico. The Clovis signature was continent-wide and appeared, on the evidence available, to arrive almost simultaneously around 13,000 years ago. The geographic story assembled itself. First, the land bridge. During the last glacial maximum, the period of maximum ice coverage that peaked roughly 26,000 years ago, sea levels were more than 100 meters lower than today. Beringia, the shallow shelf between Siberia and Alaska, was dry land. A broad, grass-covered plain the size of Western Europe, exposed and available. Humans had been in Siberia. The logical inference, they walked across. Second, the corridor. Between the two massive ice sheets that covered Canada, the Cordilleran ice sheet to the west and the Laurentide ice sheet to the east, there was believed to be a gap, a passageway running south through what is now Alberta and British Columbia. As the ice retreated, the corridor opened. Hunters followed megafauna through. They emerged onto the Great Plains. They became Clovis. Three things locked this model in place for 80 years. First, Clovis artifacts were exceptionally durable and easy to identify. Stone tools last. They showed up at hundreds of sites. They were datable and consistent. The absence of older evidence felt like confirmation, not a gap. Second, every serious pre-Clovis claim that emerged, Meadowcroft in Pennsylvania, Pedra Ferrada in Brazil, early dates from South America, was challenged aggressively. Critics questioned contamination, stratigraphy, methodology. The Clovis First community earned the nickname the Clovis Police. Sites that threatened the model were scrutinized to failure. Third, and most importantly, White Sands was not where anyone was looking. The Tularosa Basin in New Mexico was understood to be a harsh environment, gypsum desert, extreme heat, conditions that destroy organic material. No one expected ancient DNA, ancient seeds, or ancient footprints to survive there, so no one had seriously tried to extract them. The error was not incompetence. It was the rational allocation of scientific attention in the direction of evidence that already existed. Now here is the problem the model always had, the one that sat quietly in the literature for decades without resolution. The last glacial maximum, the period between roughly 26,000 and 19,000 years ago, was not merely cold, it was geologically imprisoning. During that window, both the Cordilleran and the Laurentide ice sheets were at their maximum extent. The ice-free corridor was not a gap. It was sealed. A 2022 study published in the Proceedings of the National Academy of Sciences by a team led by glaciologists at multiple institutions using cosmogenic exposure dating of 64 rock samples confirmed that the ice-free corridor did not fully open until 13,800 years ago, plus or minus 500 years. Not during the last glacial maximum, after it. If the only route into the Americas was through that corridor, and the corridor was closed until 13,800 years ago, then nothing older than roughly 13,500 years should exist south of the ice. Clovis fits neatly inside that window. Everything was consistent, and then Bustos and Bennett scraped back the sand. The challenge in dating white sands was that the footprints themselves are pressed into fine-grained gypsum-rich sediment. You cannot date mud directly with standard radiocarbon methods. There is no organic carbon in the substrate. What the team needed was organic material that had been deposited at the same time as the footprints, sealed in the same stratigraphic layers, and preserved by the same cold, dry conditions that had kept the sediment intact. They found it in the form of seeds. Rupia serosa is an aquatic plant, a thin-stemmed floating freshwater grass that grows at the margins of shallow lakes. 22,000 years ago, the Tularosa Basin was not desert. It was the floor of a large, shallow Pleistocene lake called Lake Otero. The lake had shorelines and muddy margins. People walked along those margins. And as they walked, seeds from the aquatic vegetation drifted down and settled into the same wet mud that preserved their footprints. USGS research geologist Jeffrey Pigati and his colleague Kathleen Springer, both from the USGS Denver Federal Center, led the dating work. They extracted seeds from layers directly above and directly below the footprint-bearing horizons, bracketing them in stratigraphic language, and submitted them for accelerator mass spectrometry radiocarbon dating. The technique is among the most precise available for organic material in this age range. The seeds from the layers above returned ages in the range of 21,000 years. The seeds from the layers below returned ages of 23,000 years. The footprints were sandwiched between them. The dating range, between 23,000 and 21,000 years before present. The process is something like reading the age of a page in a book by measuring the age of the ink on the pages immediately before and after it. You are not dating the footprint itself. You are dating what was deposited around it by the same lake at the same time. If the stratigraphy is intact, and at White Sands, it was demonstrably intact, the inference is sound. What the team published in Science on October 22, 2021, was the first confirmed human presence in North America during the last glacial maximum. Not close to it, not approaching it, inside it, when the corridor was sealed, when the standard model said arrival was physically impossible. Let that settle for a moment. 3 things make this finding difficult to set aside. First, what the evidence shows. The team excavated 61 footprints distributed across 8 separate sediment horizons, spanning a period of approximately 2,000 years. These were not a single event, not a single person. Based on the size and morphology of the prints, Matthew Bennett concluded that most were made by teenagers and children, with relatively few large adult prints in any given horizon. Daniel Odess, an archaeologist and chief scientist for cultural resources with the National Park Service and a co-author of the study, offered an interpretation. The adults were likely engaged in skilled tasks elsewhere along the lakeshore, hunting, tool-making, food preparation, while teenagers and children were assigned the fetching and carrying that left more tracks at the water's edge. One set of prints appears to trace a woman or adolescent male walking more than a mile, carrying a very young child, setting the child down, making a return trip alone, and picking the child back up. The footprints show the slight asymmetry of someone bearing uneven weight on one side. This was not a campsite in the conventional sense. It was a place people returned to repeatedly over centuries because the lake was there and the lake meant survival. Second, what the evidence rules out. The immediate objection, raised by several archaeologists in letters published alongside the original paper in Science, was the possibility of an old carbon reservoir effect. Rupia serosa is an aquatic plant. Aquatic plants absorb dissolved inorganic carbon from the water. And if that water draws from ancient underground sources, what geochemists call hard water, the dissolved carbon can be thousands of years older than the actual age of the plant. This is not a fringe concern. It is a real and documented phenomenon that has misled researchers before. The rebuttal came in 2023 in a follow-up study published in Science by Pigati, Springer, and their USGS colleagues. They used two entirely independent methods. First, AMS radiocarbon dating of terrestrial pollen grains extracted from the same stratigraphic layers as the seeds. Pollen comes from land plants, not aquatic ones. Land plants are not exposed to hard water. If the pollen and the seeds agreed, the reservoir effect hypothesis was eliminated. They agreed. Second, optically stimulated luminescence dating of quartz grains from the sediments within the footprint-bearing sequence itself. OSL dating measures the last time mineral grains were exposed to sunlight. It is entirely independent of radiocarbon methods. The OSL ages agreed with both the seed and the pollen dates. 3 independent methods, 3 separate lines of evidence, 3 convergent answers. The same range, 23 to 21,000 years before present. Third, what the evidence implies. If people were in southern New Mexico 23,000 years ago, during the last glacial maximum when the interior ice-free corridor was sealed, then the migration into the Americas was not what the textbook said. The corridor was not the route. Something else brought people here. The most widely supported alternative is the Pacific coastal migration theory, sometimes called the Kelp Highway hypothesis, which proposes that early peoples traveled by boat or on foot along the deglaciated coast of the North Pacific, following productive marine ecosystems from northeastern Asia, southward, eventually reaching Central America and continuing east. That coastline is now largely submerged under 100 meters of sea level rise. The archaeological evidence for it may be irretrievable, but White Sands says it must have existed. If you have been following this channel's coverage of ancient DNA and the evidence that keeps forcing science to revise the settlement history of the world, the White Sands story fits a pattern that you will recognize. The discovery that was impossible according to the reigning model, the initial resistance, the methodological challenge, the independent confirmation. Before we reach the part where the debate still sits unresolved, if this kind of evidence-driven storytelling is something you want more of, subscribing is the best way to make sure you do not miss the next chapter of this. The counterarguments have not disappeared. I want to be honest about that. 2 researchers I respect have read the same dataset and arrived at conclusions roughly 7,000 years apart. That gap matters, and it deserves more weight than it typically gets in popular coverage. David Rode, a research professor at the Desert Research Institute in Nevada, and colleagues published a challenge in 2024 arguing that the luminescence dating methodology used by Pigati's team has its own vulnerabilities, specifically that the OSL samples were positioned below the human and megafaunal trackways rather than within them, making them age minima rather than true bracketing dates. Rhodes' team has argued that the hard water effect on the rupia seeds may not have been fully corrected, and that the true ages of the footprints could be considerably younger than the published range, possibly as recent as 16,000 years before present. Pigati's team has responded in the literature, maintaining that the stratigraphic context places the OSL samples within the footprint-bearing sequence, and that the convergence of 3 independent methods makes systematic error across all 3 simultaneously implausible. In January 2025, a study by a separate team using radiocarbon dating of the mud matrix directly, rather than seeds or pollen, returned an estimated range of greater than 23,600 to 17,000 calibrated years before present. The lower bound of that range still predates the opening of the ice-free corridor. Here is what is not in dispute, regardless of which end of the age range you accept, even at 16,000 years before present. White Sands predates the opening of the ice-free corridor by more than 2,000 years. Even the most conservative reading of the evidence requires a route other than the one the textbooks described. The Clovis first model is gone. The only remaining question is exactly how much earlier than Clovis the first Americans arrived, and by what path. I want to step back from the sediment layers and the OSL methodology for a moment, because there is something else at work in this story that deserves to be stated clearly. Kim Charlie is an enrolled member of the Pueblo of Acoma in New Mexico. She has visited the White Sands footprints multiple times. She has helped uncover some of them. Speaking to reporters after the 2021 publication, she said this: "Thousands and thousands of years ago, her ancestors walked this place." She noted that the Acoma language has a word for camel. At White Sands, the footprints of ancient camels, now extinct, appear in the same sediment layers as the human prints. The language preserves something the science had not yet caught up to. The Pueblo of Acoma, along with several other native nations and pueblos of New Mexico, has been collaborating with the research team at White Sands through the National Park Service's Tribal Historic Preservation Office. That collaboration is not a formality. The research protocols at White Sands have been shaped by that partnership. The footprints have not been excavated beyond what is necessary for dating. The site is protected, not displayed. The involvement of indigenous communities in determining how the evidence is handled is not secondary to the science. It is part of it. For most of the 20th century, the Clovis first model carried an implication that was rarely stated directly but was always present, that indigenous oral traditions claiming deep continuous presence in North America were not scientific knowledge, and could therefore be treated as stories rather than evidence. The White Sands footprints do not literally confirm any specific oral tradition, but they dismantle the confidence with which Western science once claimed to have the definitive answer. And in doing so, they open a question that indigenous communities have never stopped asking. What if the people who have been here did not arrive the way science decided they arrived? The Cherokee Nation's engagement with its own genetic origin story, which this channel has covered separately, shows what happens when indigenous knowledge and scientific methodology work in genuine partnership rather than in opposition. At White Sands, that partnership is happening in real time. There are currently over 500 native nations and tribal communities recognized in the United States. The peoples of the Pueblo, the Navajo Nation, the Apache, and dozens of others whose ancestral territories include or border the Tularosa Basin have not been waiting for science to tell them when they arrived. They are not the subjects of the White Sands story. They are among the people to whom the story belongs. The medical implication of the timing question is something that almost no popular coverage has addressed, and I think it is underappreciated. If the ancestors of today's Native American populations were present in North America not 13,000 years ago but 23,000 years, or possibly longer, then the timeline of genetic adaptation to this continent is 10,000 years longer than the models used in medical research have assumed. This matters in concrete ways. Native American populations have significantly elevated rates of type 2 diabetes, cardiovascular disease, and metabolic syndrome compared to most other populations. For decades, explanations have invoked rapid dietary change after European contact, the trauma of colonization, and the disruption of traditional food systems. Those factors are real, but some researchers have also pointed to a potential genetic dimension. That populations who spent longer in specific environmental conditions may have developed specific metabolic adaptations that interact in particular ways with modern dietary patterns. If the actual period of adaptation to North American environments is 10,000 years longer than current models assume, the population genetics research attempting to understand these health disparities needs to be rebuilt on a different foundation. Genetic drift over 23,000 years produces a different signature than drift over 13,000 years. The medicine that emerges from that research, and several major studies in precision medicine are currently drawing on Native American genomic data, needs to work from accurate temporal assumptions, not inherited ones. The footprints in the gypsum mud are not just archaeology. They are a correction to a baseline that affects living people, somewhere near the eastern margin of what was once Lake Otero. On a day approximately 22,000 years ago, a child walked along the shore. We know the child was small. The footprints are narrow, the toes closely spaced. We do not know the child's name, the language they spoke, or the name their community gave to the lake. We know they were barefoot, flat-footed, walking at a pace that suggests neither urgency nor fear. We know they turned around at some point because the tracks double back. Perhaps they were sent to fetch water. Perhaps they were playing. Perhaps they simply wanted to see how far the shore went before the reeds closed in. The entire arc of what we call human history, the first cities of Mesopotamia, the pharaohs, the Zhou dynasty, the Roman Empire, the Aztec, the Mongol, the Industrial Revolution, everything that has ever been written down or carved into stone or transmitted as memory fits inside the time between that footstep and this sentence. And still, it does not reach back far enough to touch the moment when that child pressed their foot into the mud of Lake Otero and left a mark that 22,000 years of geological accident, wind, and the slow accretion of gypsum would eventually deliver to a team of scientists on a windy morning in 2019. There are, by current estimates, hundreds of thousands of fossilized footprints preserved in the White Sands area, human and animal both. Overlapping, crossing, returning, disappearing into layers not yet excavated. Pigati and his team are continuing to work the site. The conditions that preserved what has already been found were exceptional and are not guaranteed to repeat. The child who walked by the lake had no way of knowing that the people who would eventually find their footprints would be the inheritors of a world the child could not have imagined. But the child's descendants, the people who built the Pueblo communities who named the camel in their language, who have been here through every change in climate and culture and governance and catastrophe that this continent has seen, they are still here. The footprint is theirs. The story is theirs. The question that stays with me is not whether the dates are exactly 23,000 or slightly less. 2 independent laboratories, 3 independent methods, and a body of evidence that has now survived 4 years of the most aggressive peer scrutiny this field has seen. The question that stays with me is this: if the footprints at White Sands preserve 2,000 years of continuous return to the same lakeshore, 2,000 years of children and teenagers walking the same muddy edge of the same water, how many more sites like this exist beneath the desert? Beneath the sea, beneath the sand that has been building up for 20,000 years in every direction? And what were those people doing in the millennia between their arrival and the moment the lake finally dried and the mud turned to stone? We are still looking, and honestly, that is the most important part of this story, not the answers, the scale of what remains to be asked.